All right, so with this, we're going to use our Lewis dot structures and our understanding of geometry and electronegativity to be able to determine the polarity of individual bonds and then the overall molecule as well. So for our first molecule, we are given HF. Once you total up your valence electrons, you should get 8 valence electrons in your structure, and your Lewis structure should look something like this. Now I can start marking up my molecule. In a bond, I'm going to draw an arrow that points towards the more electronegative atom, which is fluorine in this case. And at the back of my arrow, I put a little cross to indicate a plus sign, that the back end of the arrow is more slightly positive, and the front end of the arrow is more slightly negative. Now, if I look, this arrow isn't canceled out by another arrow. And what that means is that my whole molecule is polar to the right. Now let's try H2O. And with H2O, you really have to think about the geometry of the molecule as well. So when you draw your Lewis structure, you should also have 8 valence electrons. And your Lewis structure should look something like this. Now I will annotate, point my arrows and my bonds towards the more electronegative atom. And if you had drawn this molecule in a line instead of bent, you would have seen 2 arrows cancel each other out. But remember, the geometry of H2O is not linear. It's bent because of these 2 lone pairs and the 4 total electron domains around my central atom. And so these lone pairs carry negative charge, and I have arrows pointing in that direction, so these arrows don't cancel out. My whole molecule is polar in this direction. All right, let's try the next one, SiCl4. When you calculate your valence electrons for this, you should end up with 32. And your Lewis dot structure should look something like this. Now you are going to annotate the polarity of your bonds, and your arrows are going to point out towards the more electronegative element, which in this case is the chlorine. Now if you look, all of these arrows are going to end up canceling out. And the shape of this molecule is tetrahedral, which means all of my chlorine atoms are the same distance from each other and from the center. And so even in 3 dimensions, these all do cancel out, and this molecule will end up being non-polar. So now let's try the last one, CH3Cl. You should end up with 14 total valence electrons, and your Lewis structure should look something like this. You could put the chlorine in any of these 4 positions. As long as your arrows are pointing in the right direction, it will still be correct. I chose the right side just because that's what I chose. Now I'm going to annotate my bonds. Between carbon and hydrogen, carbon is more electronegative. So I'm going to draw those arrows. But between carbon and chlorine, fluorine is more electronegative. So I'm going to draw that arrow. And now if you notice, my up and down arrows cancel each other out, but my left and right arrows do not cancel each other out. And so this whole molecule is polar in the direction of your chlorine atom.